Grade 10s. In this lesson, we're going to be looking at chemical change. But what is chemical change? Chemical change is when there is actually a change in the chemical nature of the substances involved. New chemical substances are formed, existing bonds are broken, and new bonds are formed. And because these existing bonds are broken, we need large amounts of energy. In fact, much more energy is needed for chemical change than for physical change. So there are two types of chemical change that we're going to be looking at. The first is decomposition, and the second is synthesis. Decomposition. In this type of reaction, your compound breaks down into two or more new chemicals. Most decomposition reactions need lots of energy to break down the reactants, and this energy is supplied in three different forms. You can either heat it, which is what we usually do, we put it over a Bunsen burner or on a stove, or we can stir it, and by stirring it, we increase the average kinetic energy, or we can use electrical energy. So the first example of decomposition we're going to look at is actually electrolysis. And electrolysis is when we take electrical energy, we pass an electric current through an acidified water, a solution, and it's going to be broken down into hydrogen and oxygen. Let's look at that, shall we?
If we connect an electrolyzer filled with distilled water to a source of direct current, we can observe a slow evolution of gases. After some time, we notice that the volume of the gas released at the cathode is double that of the gas formed at the anode. To identify the gaseous products of the reaction, we collect each gas in a test tube and check its behavior in the presence of a glowing splint. The characteristic cracking sound proves that the gas released at the cathode is hydrogen. The ignition of the glowing splint is evidence that the gas collected from the anode is oxygen, which supports combustion.
Right, so there we saw that we broke down water into hydrogen and oxygen. So that's one form of decomposition. Now let's look at another. We can decompose hydrogen peroxide. It can break down into water and oxygen, and we need a catalyst. In this case, we're going to use a catalyst, manganese dioxide. So let's look at that video. Now, we're not looking at the rest of the video because it just looks at uses of a hydrogen peroxide, but you did see there that the hydrogen peroxide broke down into water and oxygen, and they tested the oxygen with a glowing splinter. Now we get synthesis reactions. Synthesis reactions are really just when we make a new product. Before we were taking a product and breaking it down into different compounds. Now we react two of the reactants and chemically combine to form one product. The products will have different chemical characteristics to the reactants. Often large amounts of energy are released in these reactions. So let's look at an example. Now the first one is hydrogen reacts with oxygen to form water. So do you remember we used acidified water and we sent electric current through it and we get hydrogen and oxygen. Now we're going to take hydrogen and oxygen, combine the two, and we are going to end up with water. This is a very exothermic reaction. Watch the video.
Today I'd like to show you a quick demo for mixing hydrogen and oxygen to make water. You need to wear iron ear protection because it will be loud and it does involve explosions. So take a bottle, mark it off into thirds, and then you'll fill 2/3 of it with hydrogen and 1/3 with oxygen. As you know from the formula for water, H2O, that's the correct balance, 2 hydrogens to 1 oxygen. So we're going to make the oxygen by combining peroxide with regular chlorine bleach that will release oxygen. And we'll bubble it into the bottle that I had marked off in thirds. I filled it up with water so that the bubbles of oxygen will just displace the water, and I'll know when I get to that first 1/3 mark. So now to make the hydrogen, we're going to take aluminum foil, put that in the bottle with the hydrochloric acid, which I'm getting from the works. Make sure you get the 20% hydrochloric acid version of the works. It should say it on the front label. That will work better than the other versions. Once you get the hydrogen bubbling, again, go ahead and bubble that into the bottle to displace the other 2/3 of water. Once you see bubbles come out the bottom, then you're going to know that you filled the bottle all the way. So then go ahead and cap it, and you're ready to do your demonstration. Now you can make other ratios like 50-50, or say 2/3 oxygen to 1/3 hydrogen, and you'll get different reactions. Because they're not perfect, they won't be as loud. I'm just demonstrating the best reaction. It's very loud. Wear your ear protection. The mic's going to cut out because it's so loud, but trust me, your ears will be ringing if you don't. Kids love it in class, so you know, unfortunately you can't do it in slow motion, but you'll definitely get a nice jump out of it.
So unfortunately you couldn't see the formation of water in the video. What actually happens is that the water is vaporized, but did you see it was a very exothermic reaction, gave a lot of energy, and it was very loud. Now let's look at magnesium burning in oxygen to form magnesium oxide. Right, so then again, what we did was we took magnesium and we burnt it in oxygen. It forms magnesium oxide. Again, did you see bright white lights? The cool thing about magnesium is it burns the bright white light in oxygen, still does it in air. So if you ever see fireworks and you see them very bright white fireworks, that's magnesium. It's magnesium powder in the fireworks. Right, so please note, in both reactions, energy in the form of heat was needed to start the reaction, but both reactions were incredibly exothermic. They gave off more energy than they initially took in. Right, thank you, grade 10s. I hope that you learned a lot about chemical change in this lesson.